Hello Flight developers, I hope you're doing well. The last time I created a video about PX4 development environment was back in 2017, and many things have changed since that time, and many steps that I covered in that video are no longer supported or they don't make sense anymore. And I should admit that video quality and tutorial quality of that video wasn't that good. So I decided to create an update in 2000 or 2023 just to introduce you to some new features today and walk you through some steps and how I recommend you to set up your development environment in 2023. In this video, I'm going to introduce you to WSL and walk you through the steps such as cloning the repository, building the code for the first time, running the JMavsim and Gazebo Simulator, and do the integration with Visual Studio Code and QgroundControl. Before I start, let's have a brief introduction about why you need development environment in the first place. For those people that are just joining the developer community and don't know what they are facing with. Basically, if you're just a normal user that just want to install PXHug on your drone and do the fly and enjoy it, you basically don't need development environment at all. But I strongly advise you to do so because it teaches you a lot. And if any of these 5 items applies to you, I strongly advise you to watch this tutorial and set up your development environment. First of all, if you need a software in the loop or even hardware in the loop simulation with Gazebo, JMavsim, AirSim, or any other simulator out there, to learn the logics behind the scene of the PX4 or even the flying logics. For example, if you want to create a mission, you want to upload a mission to PX4 and you want to know what happens if you suddenly change the altitude, or what happens in the middle of the mission. You, for example, tell the drone to go somewhere else, or you want to, for example, send an RTL command to the drone. You want to see how will it perform before sending your real drone outside and risking your drone and other people out there. So you can basically test and try the logics, test and try the mission virtually inside the virtual world with a virtual drone, with a virtual PXHug without risking anything. So this is the best option. So you can use software in the loop simulation inside the JMavsim or any other simulators. For more advanced users that use, for example, have used the Mavros or MavSDK or PyMavlink, you know that you can't risk your aircraft, you can't risk your drone to just test your codes for the first time. You might have a bug inside your code. So you basically use the simulator to test your code and see how the drone will react to your scripts. For example, you have created an off-board mission or created some MavSDK command and you want to test if that works as you expected. So you will use the simulators and do the software in the loop simulator to make sure your code works great. Or maybe you have created a PX4 module. If you don't know about PX4 module, I have created a video series about that in 2019, I guess. You can go ahead and watch that video. You can create a separate custom PX4 modules. And for the first time, if you want to test it, you better use software in the loop simulation. And basically, you can test and try everything. You can go ahead and change some specific parameters. For example, the cutoff frequency, maybe some PID gains. You go ahead and change the gains for position holding, or change the gains for the rate control or attitude control, and see how the aircraft behave. Although it is a virtual environment and it's not that precise, but if you change the gains, you can see the actions. For example, you can see if I reduce the P gains, what will happen. So it's very good for beginner PXHug users to interact and see how each parameter change the flight without risking your drone actually. For more advanced user, if you have changed your firmware, if you have manipulated the code of the PX4, or you have created a custom PXHug module, PX4 module, as I told you in the last section, you need to build your own firmware. Actually, 99% of the PXHug users don't use this. You usually use the official firmware, but if you know what you're doing and you're an advanced guy and you know what exactly you're doing, you can build your own firmware and upload it to the PXHug. In that case, you definitely need a development environment setup. And the last item is just for fun and just for learning and for tutorial. Doing these things teach you a lot about PXHug. You understand the logics behind everything. You understand how PXHug works and behaves. So go ahead and set up your development environment today if these items is not tempting you to do. Okay, what are the different options available? If you have a dedicated Linux system, you are good to go. Just go ahead and install it on your Linux. If you are a Linux user, this is the best recommended options to install and set up your development environment on a dedicated Linux system. So that's another story. If you have macOS, again, you are good to go. You can install everything on your macOS system, but basically, for example, the AirSim is not supported in macOS, or some small limitations. If you have Linux, Ubuntu Linux inside a virtual machine such as VMware Workstation, that's again good. You can use virtual environment just like what I did in the last my old tutorial. But remember, if you use VMware Workstation and virtual machines, you are running a whole other operating system. So you better have a good system and have enough RAM in your computer. Okay, what to do if you are using? What should you do if you have Windows system? Back in the days, if you had Windows, you were very limited. The only options you had was to use the PX4 Windows toolchain that actually created the environment virtually for you, and you should interact with that with Sigbin. And that would basically just let you work with the JMavsim only. The Gazebo wasn't supported in that video. In my old video, I walked you through this old method, and it's also applicable right now. You can use PX4 Windows toolchain today as well. But the most modern method and newer method is WSL, Windows Subsystem for Linux. So what is WSL? Basically, WSL is actually a virtual environment or a subsystem inside your Windows that is created natively by Microsoft. So Windows Subsystem for Linux is a feature of Windows, it's officially supported, that allow developers to run a Linux environment without need for a separate virtual machine or dual booting. There were days back in the days, Microsoft didn't have a good relation with Linux. It wouldn't let you interact with Linux, but from 2020, the story has changed. Microsoft is embedding Linux kernel inside itself. So basically, if you have Windows 11, you basically have a Linux kernel inside it as well. You have PowerShell. PowerShell is basically a Linux terminal. So nowadays, many Linux developers can do their jobs natively inside Windows. So that's very good news. We can set up our environment inside our Windows without need to dual booting or have virtual machine. And it is basically very fast. It's faster than virtual machines and use less system resources. There are two versions of WSL1 and WSL2. WSL1 is the older method. It was basically experimental. In WSL, you only have access to the terminal of the Linux kernel, and you couldn't use the GUI apps. For example, you couldn't have the QgroundControl on Linux version because it was only the command line. But with WSL2, many problems have been solved, many improvements have been made in the core, and you could basically use the Linux GUI inside your Windows, which is very fun. You can have, for example, you can install a Qt creator inside Linux and open it just like any other Windows app inside your Windows. That is very fun. Okay, how to install WSL2? Again, because WSL is a very new feature, it's experimental and new, the steps are being changed every day. So maybe by the time you're watching this video, there will be a better way and easier method for installing WSL2. So go ahead and search WSL and check the Microsoft or PX4 documentation to see if a newer and easier method is available or not. Today, the best method that I can advise you to use is using Microsoft Store with just one click. Go ahead in Microsoft Store if you have Windows 11 or Windows 10 version 2004 or later. Go ahead and open your Microsoft Store, log into your Microsoft Store and search for WSL and install it with just one click. It will go ahead and do all the configuration your computer needed for you, and it will basically install Ubuntu by default for you and launch the Ubuntu. So it will do everything for you with just one click. And if it didn't install the Ubuntu by itself, you can go ahead and install Ubuntu just by searching in Microsoft Store. For example, you can go ahead and say Ubuntu. Or if you are, for example, want to create a hacking lab, you can go ahead and install Kali Linux, just like Ubuntu. I'm going to show you the steps here shortly. The older method was using the command line. You could still open open the PowerShell and just run the command WSL or WSL.exe -- install. That would basically go ahead and configure your Windows subsystem for Linux and again install Ubuntu by default. But using Microsoft Store is recommended because it is auto-updated, so you don't need to check for update periodically. It automatically check for update and download it for you from the Microsoft Store, so you will always be up to date. If you have older Windows 10, you could still use WSL-2 with some extra steps, and your computer should support Hyper-V virtualization support, which there are lots of tutorials about that in Microsoft websites and even YouTube, so you can go ahead and search. I will put some of the links in the description if you want. Basically, you need to enable the Hyper-V virtualization from your motherboard BIOS system and enable some of the features inside your Windows. Again, the tutorials are available, but I strongly advise if your computer supports upgrade to Windows 11 or the latest version of Windows 10, then you will be good to go. So what are the steps after installing WSL-2? What are the steps that we're going to cover in this video? We're going to clone the PX4 repository from GitHub and download all the submodules of that. Then we use the ready-to-use bash file, which has done everything for you. You don't need to do the steps one by one, just like old days. You just run a single bash file and it will automatically download all the subsystems it needs and prerequisites and requirements and do all the configuration for you. Then we're going to build the code for the first time and run the simulator such as JMavsim and Gazebo. These steps might need some troubleshooting, depends on your system and your configuration. I hope you won't face with any errors here, but if you do, I will guide you the steps for troubleshooting and what should you do. Then we're going to install and connect the QgroundControl inside the Linux and inside the Windows, and we're going to connect it together. And the last step in this video, I'm going to install and integrate Visual Studio Code. And basically we use the Visual Studio Code inside our Windows to communicate to the PX4 development section inside the Linux kernel. If it doesn't make sense for you, just keep up with me and watch the video. It will make sense and it's very interesting. And for the last thing, everything is well documented in PX4 documentation. So if you go ahead and open the PX4 documentation, you don't need my video tutorial at all. Everything that I'm going to do in this video, I'm going step by step from the PX4 documentation. So I strongly advise to go ahead and read the PX4 documentation, because actually maybe by the time you're watching this video, some steps at least have been changed. So PX4 documentation is definitely better than this tutorial. So at least check that out as well. Okay, without further ado, let's walk you through the steps for setting up your Windows development environment based on WSL. As I told you, every step I'm going to walk you through is based on this documentation. This is the best guide you can find. Maybe by the time you're watching this video, some steps have been changed. So go ahead and watch the documentation. Another good resource is this DevBlog board from Microsoft. It's basically a cheat sheet that tells you everything about the WSL command and also tell you that the store version is now the best solution. Again, by the time you're watching, some of them might have changed. There's also another article that I have put the link in the description for you. This is the more detailed instructions for WSL, WSL-2, changing the default version of WSL, or having more than one specific distribution, and the guide for those guys having older version of Windows 10. This page walks you through all the steps you need to do, but I assume that you already have Windows 11 or you already have the WSL up and running. So we are going to continue and focus on PX4 steps. Let's open up our PowerShell, but before that, let's install our WSL. As I told you, the best way right now is using the Microsoft Store. Go ahead and open your Microsoft Store and log into your Microsoft Store and search for WSL. That's simple. When you search for WSL, you will find a Windows subsystem for Linux. If you already have installed it, you will see that open icon. But now, if not, you're going to click it on install. It's going to download all the dependencies that it needs, and it will basically install. Maybe it will depend on Ubuntu distribution by default for you as well. Depends on the settings of Microsoft right now. Maybe you need a restart or any steps that it will give you based on the settings. After that, go ahead and search Ubuntu. Different versions of Ubuntu are available here. I recommend you use Ubuntu 22 LTS version because I found some compatibility issues with Ubuntu 20 with PX4. Right now, Ubuntu 22 works best with JMavsim and Gazebo. Go ahead and install it. It will basically install an Ubuntu version default for you. Go ahead and run a PowerShell and run it as administrator if it's your first time. Now, if you have installed Ubuntu from Microsoft Store, usually it will install an Ubuntu version by default for you. So go ahead and check it. We're going to open WSL and we're going to type WSL-help to see all the commands with WSL. It's a cheat sheet for whenever you forgot the commands. For example, WSL install or install specific distributions, WSL changing the default version, which is we are going to use WSL-2, shutdown or maybe update. If you're using a Microsoft Store, you don't need the update, it will be auto updated for you. The most useful commands is WSL-list, for example. Let's type WSL-list to see. As you can see, we already have one WSL, one Linux system available and installed, which is Ubuntu 22. This is our default version right now. We can delete it or we can install another one as well. To delete a Linux subsystem, just go ahead and type WSL-unregister and type the distribution name, which is Ubuntu-22.04. And now if you run WSL-list, it says it is you don't have any WSL installed. It will basically guide you. You should type WSL-list-online to see all the subsystem for Linux available you can use in WSL. If you have already installed from Microsoft Store, you won't need to download anymore. But if you haven't used the Microsoft Store, if you type a specific distribution name here, it will automatically go ahead and download. For example, if you want to install WSL Kali Linux, you can download it from here. Now we're going to type WSL-install Ubuntu-2204. Because I have already downloaded from Microsoft Store, it is not going to download the Ubuntu again. Just going to configure it for me. And in a few seconds, I have a Linux up and running. Just in a few seconds. As you can see, a new window is popped up. It says installing and will take a few minutes, but actually take a few seconds. I'm just gonna type a username and a simple password, and we are in. Now we are on a totally independent Linux inside our Windows. You can see we are the parent directory and the root directory is here. If you're not gonna believe it, you can go ahead and open your computer and you will see a new icon appeared on your sidebar, which says Linux and Ubuntu 22. You can directly access your Linux files within your Windows Explorer, which is really nice. Okay, now we are inside. It's a good practice to after installing the WSL, just go ahead and shut down, exit from your Linux, shut down WSL and run it again. Just a good habit. I don't think it's been necessary. WSL-list, you see again we have an Ubuntu 22. And if I type WSL, it will automatically open the default version for me. And if you want to specifically open a specific distribution, you should say WSL-D- your distribution name. Let's continue with the steps for PX4. It specifically says you better open PowerShell not as an administrator because you might end up changing some of your WSL settings. So it's better to open your WSL after you install it. You open it just like normal user. Now we're gonna type WSL-D to select our distribution and the name of the distribution, which is Ubuntu 22.04. Now we are inside. One of the most important steps is just go ahead and cd to your home directory, WSL home directory, which is stated here in the documentation as well. It's a very important steps because if you don't cd to the home directory, it will end up with some slow execution time as it is stated here in the documentation in the yellow box. So we're gonna we're gonna cd to our home directory, then we're gonna git clone our PX4 repository from the official repository. These steps can take a long time for you, depends on your network connection. It could take from maybe 2 or 3 minutes or up to 20 or 30 minutes. Make sure you are not behind a proxy or firewall that blocks some of the GitHub repositories. So you should see something like this. After a few minutes, everything should be installed without any errors. After the clone repository finish, you will find there is a new folder here, which is PX4-autopilot. Thanks to the PX4 developer, there is a ubuntu.sh file which does everything for you. You don't need to do any line of codes here. By just copy and paste this line of code, everything and all the configuration needed for PX4 will be installed in a matter of maybe minutes, or depends on your system, up to 10 minutes maybe, but it will basically finish in 2 or 3 minutes. But again, because it's an open source product and everything is changing day by day, some of the package might be missing, so you might need some troubleshooting, but 99% of all the configuration you need will be happen by just running these bash commands. So I'm gonna fast forward the video from here for you. Okay, after a relatively long coffee break, everything is executed as expected and everything is installed without any error. It will ask you for reboot your computer. Basically, you need to exit the Windows subsystem from your Windows subsystem and shut down the WSL and run it again. WSL shutdown, and you can open the WSL again after that. You can go ahead and just search WSL alone if you have only one distribution installed, or if you have more than one distribution, you can go ahead and install, go ahead and type WSL-D and Ubuntu-22.04. Okay, by now we should have everything okay and running if you won't face with any unexpected errors here. If you have installed Ubuntu 22 and installed all the packages successfully without any error, you shouldn't face with any errors right now. Let's cd to the home directory and cd to the PX4-autopilot. Now you can see all the folders are available here, all the files. Now we can go ahead and build our software in the Loop Simulator to make sure everything is installed. But let's put one step ahead and run make PX4 software in the loop for JMavsim. And let your computer build. This step, based on your computer performance, can take about 30 seconds to maybe 4 or 5 minutes. Okay, JMavsim is running. Hopefully it will run for you as well. You can see there, you can see it is based on Windows. WSL-2 supports GUI as we expected. There's this window is open in the Linux kernel. As you can see from the Windows section and the sidebar and the title bars, you definitely understand that it is different than other Windows. Okay, we can run the commander takeoff to see yes it's working, and we can also run commander land to make sure that it's working. Right now everything is happening inside the Linux kernel and it is being shown in the Windows section. Some magic is happening behind the scene, but it's just making the world easier for us that we used to use Windows most of the time. And the next step is to use Gazebo Simulator, which is a little bit more advanced. But before that, let me help some of you that you might end up have some problem with JMavsim, especially in the older version of Ubuntu. One of the most common problems with JMavsim is the JDK version compatibility issues. If you search the expression changing the JDK version in the Ubuntu, you will find this topic in Stack Overflow that helps you how you can change the default JDK version. If you copy and paste this command, which is sudo update -alternatives--config java, you will see all the JDKs installed on your Ubuntu version, which is I have already installed Java 11, Java Open JDK 11. Your system might be different. One of the most common issues that I found with JMavsim is having the wrong version of JDK. You can install the JDK version 8 or maybe 13 and see which one works better for you. There are some documentation for that here in the PX4 documentation as well. JMavsim works based on Java, so there are lots of Java errors here. In the troubleshooting, it has introduced some of the most common errors as well. For example, it says here with Java 11 and 14 you shouldn't find any problems, but it depends on your system's configuration. Another common error, which is Java AWT error, which is assistive technology. There's a documentation here. You should change a specific line of code in the accessibility properties. There are also some common issues with macOS that it is stated here. So hopefully you won't need to see any of this troubleshooting, but if you do, go ahead and search for these troubleshooting pages, and most of the time the problem is with the JDK and Java versions. So go ahead and install OpenJDK other version and check the compatibility issues. Okay, let's make clean, and this time we're gonna make PX4 software in the loop Gazebo. Gazebo is a little bit more advanced simulator. JMavsim is basically, it supports only multi-rotors, quad-rotor, a very simple environment that you can only use, check some of your codes and just fly your drone in a virtual environment. But Gazebo gives you much more flexibility. You can design your world, you can design the environment, you can design your specific drone, and so on. Okay, just as I expected, Gazebo opened successfully without any error. Just as always, if you face with any errors, most of the common issues with Gazebo is that some of the libraries might be missing or have some compatibility issues. So if you face with any error, look at the error stacks and find the specific library that is missing. Go ahead and search the library name inside Google and install the library manually. This is usually the case. And sometimes if you make clean or make dist dash clean, some of the corrupted files will be clean and will be good to go. Again, we're gonna type commander takeoff and commander land to make sure that it works. The next step is to connect our QgroundControl to our simulator. Now, just to sum it up, we have a virtual PXHawk in the kernel Linux. Then we have a virtual environment, which can be a Gazebo, which can be JMavsim, which can be Flight Gear, X-Plane, I don't know, AirSim. But the next step is to have a QgroundControl instance, which is our ground control station. There are two methods which you can run QgroundControl inside your Windows, or you can install QgroundControl on the Linux. I prefer the Windows version of QgroundControl. It's a bit more comfortable, but I'm going to show you and demonstrate it for you, both methods. First, we're going to install the QgroundControl Linux version inside our Subsystem Linux. So basically everything right now will be inside our Linux. I'm going to create a directory in my home with make directory QgroundControl to have everything organized. I'm going to cd to the QgroundControl. And now we're going to download the executable file for QgroundControl. As here stated in the documentation, you should go to the Ubuntu download sections and copy the latest version or any specific version that you want to install. I'm gonna copy the link for the latest version and paste it here, and should be good to go. After installing, downloading the file with wget, you should change the file to the executable with the simple chmod or chmod command. You will change the file to the executable file. We're gonna add it as executable, and now it is shown as green. Now we should basically be able to open it using run it with this command, but we're gonna face with an error which is new for me. I'm saying this for the first time. It basically says that the fuse is not installed. Actually, I'm not sure what is fuse. It should be something related to the graphical environment or something with QgroundControl. I'm gonna pause the video and we'll come back to you when I found the solution. So after a few minutes searching Stack Overflow and GitHub for the issues, I found that we have two problems here in QGround in Ubuntu with WSL. First of all, you should copy and paste sudo apt-get install fuse 3. On Ubuntu 22, you need to install fuse 3, so just go ahead and copy this command. And the second issue that you might find, which is the next step after you install the fuse, you will find this error which says error while loading the shared libraries for libpulse. Another guy asked this question a few months ago on GitHub, and basically he stated the solution by himself here. He had the same problem. He described the problem here. And the solution was just go ahead and install the libpulse-dev. You go ahead and copy this command, sudo apt-get install -y for prompting the yes, and libpulse-dev. After that, the problem will be solved. But for this guy, the problem didn't solve completely. His map just corrupted, but hopefully we won't have this problem. I'm gonna sudo apt-get install libpulse-dev and run the QgroundControl, and basically we are good to go. It's working. You can always find solutions on the internet. So if you find any problems, go ahead and search the forum, search GitHub issues and the Stack Overflow. Those are your best friends while coding and developing. Okay, right now the QgroundControl is running inside the Linux kernel. Now we're gonna create a new tab. Again, type WSL to have another tab in our WSL. Now we're gonna cd to a home directory, cd to PX4 autopilot, and again makes PX4 software in the loop. Let's run the Gazebo this time because it's already compiled. Hopefully the QgroundControl will automatically connect to the Gazebo here. Yes, it is connected. Now we have a virtual environment, a virtual PXHawk, and a QgroundControl that thinks it is connected to a real PXHawk. Now we can go ahead and test and try new features or test our codes or modules inside our virtual environment. You can do whatever is possible with a real PXHawk, you can do it here. Make sure you can see in the settings section that we are inside the Linux kernel. The QgroundControl is running on the Linux version. Okay, let's demonstrate the other way, which I prefer. It's having the QgroundControl on your Windows side. It needs another extra steps, but I prefer it because I think the QgroundControl run on Windows better than Linux. The next step is just go ahead and install the QgroundControl on your Windows. Very simple. Go ahead and download and click on some next icons and it will be installed. Then open up your PowerShell again. You should run your PX4 environment on your Linux, and you should know the IP for your virtual system. Go ahead and type ifconfig, and if you don't have the net tools, you should type sudo apt install net tools to have the ifconfig prompt available, and simply type ifconfig to get the IP. The first one, as you can see, it is 172.22.36.25. It is different for your system. This is the IP of your virtual system. This is not the IP of your Windows. This is IP of your Linux system. And every time you open a Linux, it is different from the last time. So you should know the IP of your Linux system or your virtual system. And you should enter that IP inside your Windows QgroundControl station. And right now, as you can see from the title bar, this QgroundControl is opened inside our Windows section. It is not on Linux. You should come to the application settings, com links, and create a new WSL connection. I'm going to delete my own and create a new one. You should create a UDP port and copy and paste the IP of your Windows. Every time you open the Windows Subsystem Linux, you should add this IP. Basically, you should be able to let the server be empty, but for extra cautions, let's add the server here. And actually, I missed a step here and it won't connect because we should come back to here again. I will tell you what will happen in a few seconds. After your QgroundControl is listening on the port, now you should run your PX4 software in the loop. Now you run your virtual PXHawk with PX4 software in the loop, Gazebo or JMavsim or anything else. And then your Gazebo is ready. Now your ground control station should connect to the virtual environment and just work as expected. But there's a typo here. I missed a step here, so I'm gonna fix it here for you. The step that I forgot is changing the port from to 80,570. The default port for QgroundControl is 145050, but in the WSL section, when you want to send a command to WSL, you should use the port 18570. And as soon as I enter the correct port number, it will automatically connect it. Right now, a magic is happening. The QgroundControl is working inside our Windows system. The PX4 environment is running on Linux kernel, and the Gazebo is also working on Linux kernel.
Hold flight mode.
Some networking happens behind the scene, and everything is working as expected. As you can see, the QgroundControl is a little bit better in Windows environment, a little bit, I think. So I prefer to use QgroundControl on Windows and connect it using network to the Windows to Linux kernel. We can create a survey mission. Let's create a basic polygon around our mission, and let it do a simple mission for us. No, let's keep it simple and create a basic one, and that's okay. Now we can upload the mission. There is a train preview available. Basically, this tool is very good if you don't know what you're doing, if you don't know how for example, how survey works in real world. What will happen if you suddenly tell your drone to go and do a survey? What will it do in the first place? You can go ahead and test and try it here in the virtual environment, so you know, and you won't risk your drone here. You should go to the flights window and click on action, and let's say continue the mission. It will basically go to
mission flight mode,
the second waypoint, and it will do the survey automatically for us. This is just a demonstration. You can test and try whatever features you like. You can go ahead and change the parameters and see how your vehicle will react. You can change the views, change the, for example, down looking camera. You can look your drone from your home location. You can add wind in a specific direction and speed to the environment. So basically you can do anything. You can also change the gravity coefficient here.
Land flight mode.
If you one day plan to fly in Mars. You can also connect your joystick, which I have here. You can connect the joystick and basically fly your drone manually or in a position hold situation. This is also good for training and be aware how you can change from auto to the manual and again manual to auto without risking your aircraft. So sky is the limit. You can do whatever you like here without risking your drone. Basically, these are the all common general topics that I wanted to cover in this video, but I'm gonna cover two more steps which is for more advanced users. I'm gonna briefly introduce it for you. One of them is Visual Studio Code integration, and other one is flashing the firmware. Visual Studio Code, basically if you are a developer or coder, you basically have installed it, so go ahead and open it. Everyone knows the VS Code, the best IDE available for coding everything. Go ahead and open your Visual Studio Code, go to your extension settings. You basically need to download the WSL remote. With Visual Studio Code, you can have your VS Code on Windows and connect it remotely to your WSL. Basically, it will gives you more power, especially for the developers that used to use Windows and they don't like to do their coding inside Linux system. So they will basically do all the coding inside the Windows, and using this extension, which is WSL, remote WSL, it will automatically connect to the WSL and update your code inside the Linux. This is very handy tool for the Windows developers. Go ahead and install the remote WSL. As you can see, I have already installed it. If you haven't installed it, go ahead and install it. And that's it. Everything will happen for you automatically. Now you should follow the instruction which says go back to your Linux kernel and cd to your home directory, cd to the PX4 autopilot, and just type code space dot. Then everything will happen for you automatically. If it's your first time, it will go ahead and download the Visual Studio Code server that automatically manages everything behind the scene with networking and connect your Visual Studio Code to the Linux file system. After it's successfully downloaded and unpacking, Visual Studio Code will open for you, but inside the Windows, not inside the Linux, which is very good. They are sharing the same files. When you change a specific file here, the file will be changed inside your Linux, but you are editing it inside your Windows. You can go ahead and open your source. For example, you have created a new module, or you want to change an already made module. For example, the commander. Let's go to arming, arm authorization. All the CPP files are available here. If you know what you're doing, you can go ahead and change the code here, save it, and it will automatically save the file for you inside the Linux kernel. And then you can go ahead and run the code and see it in action in JMavsim and Gazebo. That's the power of software in the loop and visual subsystem for Linux. You have the power of Windows and the power of Linux all together. All the files you are editing here are accessible using Window Explorer as well. So you can see it is here, PX4 Autopilot, and all the files are available here. The next time you want to open it, you don't need to go to your WSL and type code dot. Just you can go to open recent and open this PX4 Autopilot, which says WSL Ubuntu, and everything will be open for you automatically. Okay, that's the Visual Studio Code integration. I don't want to make this video much longer because the advanced user already know these stuffs. And the last section I'm going to cover is flashing a flight control board. The only limitation that WSL has right now is this part. This is the only caveat that you will find with WSL right now. You cannot upload the PX4 Autopilot firmware directly to a board from WSL, just like how you do it in the Windows. In the window, for example, in the Linux, you could type make PX4 FMU-V5 upload, but inside the WSL you cannot do that. You should build the firmware here. For example, make PX4_FMU-V5. It will automatically go ahead and build the firmware for you, or any other boards you want. For example, I've created FMU version 5. You can click on any other build for any other boards you would like. The file will automatically copy to the build folders. You can take that file and copy it to your Windows system and upload it to your board using QgroundControl. You can basically use the Linux version of QgroundControl or the Windows file, doesn't matter. You only need to upload the .px4 files. As you can see, the file created successfully, PX4 FMU-V5 default.px4. This is the file you should copy or install on your board. You can access it through the Windows, Ubuntu, PX4 Autopilot, builds, builds, and the specific version you want, PX4 V5, and find the .px4 and .elf files here. These are the files that you should install on your board using QgroundControl. Once you located these files, you can open QgroundControl or even Mission Planner, it doesn't matter. You can open it, and from the firmware section you can select your .px4 or .elf files and upload it directly to your board. And this is the only caveat that you have, and I think it's not very important because 99.9% don't need to upload a custom firmware to the PX4, but if you do, this is the method for that. That's it. I hope this video will be helpful for you. I just wanted to create an update in 2023 for the last video I created a few years ago, and that's it. In the next videos, I'm gonna cover some new features such as air sim simulators. I don't know when, but I will create those videos for you. So make sure you follow the channel and subscribe the channel and like the video to don't miss the next videos about PX4. Until that time, good luck and have a nice day.